Hi guys, welcome to Math Vision tutorial. This class is basically for learners in differentiation. Um, Today we shall be talking about some basic rules for differentiation. If you are a learner of differentiation, after this video, you should be able to start solving some problems in differentiation using some basic rules. So take your time to follow me up. Now we are going to look at the table for differentiation over here. On the left of this table, we have four functions. And the functions are the polynomial, the trigonometric function, the exponential function, and the logarithmic function. And on the right of this table, we have its derivatives, the derivatives of those functions. So what does this table state? This table is telling us about the differentiation of those functions. So now, the table says if we have firstly a polynomial function of the form ax raised to power n. This table is telling us that the derivative of this polynomial function with respect to x, that is, the differentiation of this function with respect to x, is we using this our exponent n to multiply a to have na, and we are to reduce the exponent by power by 1. Let me come again. This table is telling us that if we have a polynomial function of the form ax raised to power n, if we want to differentiate this form with respect to x, we are going to use this exponent to multiply our coefficient a so that we have na, and we are going to reduce the exponent by 1. So now, the table now went to trigonometric functions. It's telling us that if we have sine x, if we want to differentiate sine x with respect to x, we are going to have cos x. And this table says if we have cos x, if we are to differentiate cos x with respect to x, we are going to have minus sine x. And the table said if we have tan x, if we differentiate tan x with respect to x, we are going to have sec squared x. And this sec squared x is also known as the reciprocal of cos squared x, that is 1 over cos squared x. So now, this table now tells us about exponential functions. It says if we have exponential x, whenever we differentiate exponential x with respect to x, we are going to have exponential x. And also, this table now talks about logarithmic functions. And the kind of logarithmic function it's talking about here is the natural logarithm, which we call the ln. This table says if we have ln x, whenever we differentiate ln x with respect to x, we are going to have 1 over x. So also, in today's class, we will lay more emphasis on chain rule. This chain rule is very, very important as we'll be using this chain rule to solve some problems in today's class. So now, what does chain rule state? Chain rule states that if y is a function of u, where u is also a function of x, then the differentiation of y with respect to x, that is dy dx, is equals to dy du multiplied by du dx. Let me come again. Chain rule state that if y is a function of u, where u is a function of x, then dy dx is equal to dy du multiplied by du dx. So please note this formula for chain rule and also study this table carefully, because on this table is your power tool. This table is the tool you need in solving any differentiation. You have to know this table offhand. Like for instance, if I ask you that what is the differentiation of cos x with respect to x, I expected you to be able to tell me that the differentiation of cos x with respect to x will give me minus sine x. It is a table you ought to know offhand. So take your time to study this table. And also don't forget to study this chain rule and note the formula. So now let's move into some examples. Now from the first example, we are told to differentiate the following functions with respect to x. So now, the first function here is y equals to 3x squared. Second one is y equals to 9x cubed minus 3x squared plus x. Thirdly, we have y equals to 8. Fourthly, we have y equals to sine x. And for the fifth question, we have y equals to cos x, we have y equals to tan x, y equals to ln x, and y equals to exponential x. So now let's see the solution for those problems. Okay, now this is y equals to 3x squared. Using the rule for differentiating polynomial, the rule says we are going to use the exponent to multiply our coefficient na, and we are going to reduce the exponent by 1. So using this rule now, when we use 2 to multiply the coefficient, we are going to have 6. You write back your s. Instead of writing the exponent of 2, the rule says you should reduce the exponent by 1, and here we are going to have 1. And the differentiation of 3x squared will lead to what? 6x. So now we move to the second question. The second question is y equals to 9x cubed minus 3x squared plus what? Plus x. And that x is still the same thing as 1x. So we are going to use the rule for polynomial to differentiate this function term by term. That is, we are going to do this term by term. So now, let's start with this first. We say 3 times 9, we have 27x. Instead of writing 3, you reduce it by 1 and you have 2. We move to the next one. 2 multiplied by minus 3, we are going to have minus 6x. Instead of writing 2, you reduce it and write 1 plus this is x, and this is the same thing as 1x. 1 times 1 is 1, and you write your x. Instead of writing 1, the rule says you reduce it by 1 and you're going to have 0. So now when we want to simplify this, we have this to be 27x squared minus 6x plus 1, because x raised to power 0 is 1, and 1 multiplied by 1 will give us back what? Will give us back 1. So now let's move to the third question. The third question is y equals to 8. But don't forget that 8 can also be written, we can also write 8 as 8x raised to power 0, because x raised to power 0 is 1, and 1 multiplied by 8 will give us back 8. So now we are going to rewrite 8 as 8x raised to power 0. So now y equals to 8x raised to power 0. So now we are going to use the rule for differentiating polynomial. Now 0 multiplied by 8 is 0 times, you write back your x. Instead of writing 0, the rule says you reduce it by 1. Now you have minus 1. So 0 multiplied by all this will give us what? 0. So the differentiation of 8 now is what? 0. And this led to the conclusion that when we differentiate any constant function, any constant, we are going to have 0 whenever we differentiate any constant. So now we move to the next one, which says y equals to sine x. When we differentiate y with respect to x, all you just need to do is to go to the table, because that's why I said you should note the table carefully. When you go to the table told us that whenever we differentiate sine x, we are going to have cos x. All you just need to do here is to say the differentiation of sine x with respect to x will give us cos x. And also you move to the next one, which says y equals to cos x. So now, what is the differentiation of cos x with respect to x? Check the table. The table told us that whenever we differentiate cos x with respect to x, we are going to have minus sine x. So simply here you just write minus sine x. So now also y equals to tan x. Using the table told us that whenever we differentiate tan x, we are going to have sec squared x, or 1 over cos squared x. They mean the same thing. So now this is the differentiation of tan x with respect to x will give us sec squared x, or 1 over cos squared x. So now we have y equals to ln x. This is y equals to ln x. From the table, we have that whenever we differentiate ln x with respect to x, we are going to have 1 over x. So the differentiation of ln x here is 1 over x. Also, if we have y equals to exponential x, the differentiation of y with respect to x will also give us back exponential x. So now we have some further examples. Now from these further examples, this is where we will come across using chain rule. This is the application of chain rule. The first examples we have looked at before, they are very simple. It just require you to know the table offhand, and when you know the table offhand, I told you the table is like a tool for you in solving differentiation problems. So when you know the table offhand, you will be able to move further and solve problems under differentiation. And it also works for you in the application of integration. So now, from the further examples, which is number 2, it said find the derivatives, that is the y dx of the following functions with respect to x. Now, the first one is y equals to 9x cubed minus 3x squared plus x, all raised to power 3. The second one is y equals to sine 2x. The third one is y equals to 2y equals to cos 2x squared minus 1. The fourth one is y equals to exponential 5x minus 3. The fifth one is y equals to ln 2x. The sixth one is y equals to tan 5x cubed minus 8x squared plus 1. And the last one is y equals to sine squared x. So now let's see how we can do this. Looking at the first question over here, this is a polynomial function. But the table for differentiation did not tell us about differentiating polynomials carrying another power. This is a polynomial, but this polynomial now is carrying another power. From the previous example we did, this is y equals to 9x cubed minus 3x squared plus x, or 1x. You can see that this polynomial here did not carry any power. So we went straight forward to use the rule for differentiation to differentiate it straightforward and have our answer. But this same question over here now is carrying a power of 3. How do we do this? This is the application of chain rule. The second one, y equals to sine 2x. The table did not tell us about differentiating sine 2x with respect to x. The table only told us about differentiating sine x with respect to x. That whenever we differentiate sine x with respect to x, we are going to have cos x. But now we are having sine 2x. How do we differentiate sine 2x with respect to x? Whereas the table did not tell us about differentiating sine 2x with respect to x. Now we are going to use chain rule to solve this. It's as simple as saying whenever we differentiate cos John with respect to John, we are going to have minus sine John. Whenever you differentiate sine, which name can I use? Sine Janet with respect to Janet, you are going to have cos Janet. But when you have sine Janet and you are told to differentiate sine Janet with respect to John, you can see there's a mix-up somewhere, and that is no longer straightforward. Then you are going to use what we call chain rule. That is what we are trying to look at over here now. So now let's move into solving these problems. The first one, we have that y equals to 9x cubed minus 3x squared plus x, everything raised to power 3. So now, let u equals to, what you will do is, this function, this polynomial carrying the power, you set it to be equal to u. That is, let u equals to 9x cubed minus 3x squared plus what? Plus 1x, or plus x. So now, if u is equal to this polynomial in the brackets, then your y will now be u cubed. So let u equals to this in the bracket, then next your y will be equal to what? U cubed. So now you differentiate u with respect to x. Just follow the step-by-step procedure, then you will understand better. You differentiate u with respect to x, and that means du dx. This is a polynomial. You use the rule for differentiating polynomial. This is 3 times 9 will give us 27 x. Instead of writing 3, the rule says you reduce the power by 1 and you're going to have 2. Then 2 times minus 3 will give us minus 6 x. Instead of writing 2 in the exponent, you reduce it by 1 and you are going to have 1. And if you differentiate 1x using the rule, you are going to have 1, because 1 times 1 is 1 and this is x. This now will turn to, instead of x raised to power 1, it will now turn to x raised to power 0, and x raised to power 0 is simply 1. 1 multiplied by 1 will give us what? 1. That is why we have 1 here. So now we move to the next one, that is, you are going to differentiate y with respect to u, that is dy du, and this will give us 3. There's a coefficient of 1 here. 3 times 1 will give us 3 u. Instead of writing 3 here, you are going to have 2. You reduce it by 1. And what is the formula for chain rule? The formula for chain rule says that dy dx equals to dy du times du dx. So now, our chain rule says that dy dx equals to dy du multiplied by du dx. What is dy du? Our dy du is 3u squared. This is 3u squared. Multiplied by du dx. Du dx is this, which is this over here. And finally, our dy dx is equal to 3. but this u is a function of u because we are almost at the final answer. Then you replace your u, which is equal to 9x cubed minus 3x squared plus x. You replace it back for u. Then the final answer over here now will now be 3. Your u is this, which is 9x cubed minus 3x squared plus x. But the u here is carrying square. Then you put square on it and you will write this next to it. And this is our final answer for the differentiation of this function. This is the final answer, that is the dy dx of this polynomial function carrying a power. So now let's move to the next problem. The next problem here is y equals to sine 2x. What you do, because the table did not tell us about differentiating sine 2x with respect to x, the table only told us about differentiating sine x with respect to x. So now you say let u to be equal to 2x. That is, let u to be equal to 2x. If u is equal to this 2x, then y will now be equal to sine u, which is sine u over here, like we did for the previous one. Now the next thing is to differentiate u with respect to x. This is a polynomial. When you use the rule for differentiating polynomial, you are going to have 2. So now you move to the next one. Differentiate y with respect to u. From the table, this is y equals to sine u. The table for differentiation told us that whenever we have a function of sine x, if you differentiate sine x with respect to x, we are going to have cos x. So also, when you have sine u, when you differentiate sine u with respect to u, you are going to have cos u. Do you get? So now, chain rule formula states that dy dx is equal to dy du multiplied by du dx. What is our dy du? Our dy du is cos u, this is it, and our du dx is 2, which is this. Then don't make the mistake of saying this is equal to cos 2u. This 2 is not multiplying this u. This 2 is multiplying the whole of cos u. In order not to make confusion for yourself, you now say you bring this 2 over to the back here. Then finally dy dx will now be 2 cos u. And don't forget that we always change our u back to the function of x. U was standing for 2x, then you change it back to 2x because we are differentiating with respect to x. So our answer ought to be in x variable alone. Therefore, dy dx equals to 2 cos 2x. So now let's move to the third one. Y equals to cos 2x squared minus 1. Good. This table did not tell us about differentiating cos 2x squared minus 1. The table only told us about differentiating cos 2x squared minus 1. The table did not tell us about differentiating cos 2x squared minus 1 with respect to x. The table only told us about differentiating cos x with respect to x. So now what do? We use chain rule. And the process of using chain rule is we let u to be equal to this function in the brackets. So now u will be equal to 2x squared minus 1. If u is equal to this in the bracket, then our y will now be what? Cos u. Our y will now be cos u because this is y. Y is cos 2x squared minus 1. But we have set this 2x squared minus 1 to be u. Then y now will now be cos u. Now you differentiate u with respect to x. This will now be, this is a polynomial. You use the rule for differentiating polynomial. 2 times 2 will give us 4, and this is x. Instead of writing 2, the rule says you reduce the power by 1. You are going to have 1 here because 2 minus 1 is 1. So you are having 1 here. And this is a constant function. This is minus 1. I told you that whenever you differentiate any constant, be it minus 1, be it 2, be it minus 5, you are going to have 0. So differentiation of this minus 1 is what? 0. So only here we are going to have 4x for the differentiation of this. Now we move to the other side. We are going to differentiate y with respect to u. That is dy du. So now from the table for differentiation, the table for differentiation told us that if we have sine x, the differentiation of sine x with respect to x will give us cos x. So also, okay, this is cos u. The table told us that when we have cos x, when we differentiate cos x with respect to x, we are going to have minus sine x. So also, if we have cos u, when you differentiate cos u with respect to u, we are going to have minus sine u. So now, chain rule formula states that dy dx is equal to dy du times du dx. And this is equal to, what is our dy du? Our dy du is minus sine u. This is minus sine u. multiplied by du ds. Du ds is 4x and this is 4x. So in order to write this properly, you take this 4x, you bring it to the back, and you will have minus 4x sine u. But don't forget that this u, we always change it because u is a function of x, which is 2x squared minus 1. Then you replace this for u. Then finally, we have that dy ds equals to minus 4x sine 2x squared minus 1. And this is the differentiation for this trigonometric function. So now, we move to solve the fourth question. This is y equals to exponential 5s minus 3, right? The table for differentiation did not tell us about differentiating exponential 5s minus 3 with respect to x. The table only told us about differentiating exponential x with respect to x. So how do we solve this now? We let u to be equal to 5x minus 3. Now, so that our y will now be exponential u. Don't forget that we set this to be equal to what? To be equal to u. So y will now be exponential u. If u equals to this, then y will be exponential u. That is the first thing you should do. And the next thing is to differentiate u with respect to x. And also here you differentiate y with respect to u. So now, differentiating u with respect to x using the polynomial rule. If you use the polynomial rule like we have been doing before, you are going to have 5 when you do it. You can try that on your own. And next thing for us is to differentiate y with respect to u, that is dy du. And from the table of differentiation, whenever we have exponential x, when we differentiate exponential x with respect to x, we are going to have back exponential x. So also, whenever we have exponential u, when you differentiate exponential u with respect to u, you are going to have exponential u. So now, the chain rule formula says that dy ds equals to dy du multiplied by du ds. And this is equal to exponential u because dy du is exponential u multiplied by du ds. Our du ds is 5, which is this. Then in order to avoid confusion, bring the 5 to the back and you have 5 exponential u. But don't forget that we always change our u back to the function of x because u is 5s minus 3. Then finally, we have that the y ds is 5 exponential 5s minus 3. Good. So now let's look at the fifth question, which is y equals to ln 2x. The table for differentiation did not tell us about differentiating ln 2x with respect to x. So we are going to use chain rule to solve this as well. So now, what do? You let your u to be equal to 2x. If u is equal to 2x, then our y will be ln u. Let's come again so that you don't get confused. Originally, the question was y equals to ln 2x. What you do is you let your u to be equal to 2x. That is, this 2x is equal to u now. If this is u, then y will now be ln u. Do you get? Now, if u equals to 2x, then y will now be what? Ln u. Now, the next thing is to differentiate u with respect to x. When you differentiate u with respect to x, you are going to have 2 over here. And you move to the next one, you differentiate y with respect to u. And when you differentiate y with respect to u, what are we going to have? Don't forget that differentiation of u with respect to x here, this is a polynomial function. You use the polynomial rule to differentiate it and you're going to have 2. It's very simple. You can do it yourself. Or this is 1. X is carrying exponent of 1. And 1 multiplied by 2 is what? Is 2. And you write the x back, but instead of writing y, it will now be x raised to power 0 because you will reduce it by 1. And this will be x raised to power 0. And x raised to power 0 is 1. So 1 times 2 will give us 2. So that's why the differentiation is what? Is 2. So now, the next one is y equals to ln u. You differentiate y with respect to u. This table for differentiation told us that when we have y equals to ln x, if you differentiate ln x with respect to x, we are going to have 1 over x. So also, when we have y equals to ln u, if you differentiate ln u with respect to u, we are going to have 1 over u. Follow that table carefully and you will understand better. So now, the next thing is to use our chain rule formula, which says that dy ds equals to dy du multiplied by du dx. And this is equal to, what is dy du? Our dy du is 1 over u multiplied by du ds. Our du ds is what? Is 2. And this is 1 over u times 2. And 1 times 2 you multiply these two with the numerator and you will have 2 over u. But don't forget that we always change our u back to the function of x. U was originally 2x, so you replace u to be 2x, and this will now be 2 over 2x. These two will cancel these two, and finally our dy dx is what? 1 over x. So now we move to the the sixth one, which says that y equals to tan 5x cubed minus 8x squared plus 1. So now, like we have been doing before, the table did not tell us about differentiating tan 5x cubed minus 8x squared plus 1. The table only told us about differentiating tan x with respect to x. And whenever we differentiate tan x with respect to x, we are going to have sec squared x. So also, if I differentiate tan Moses with respect to Moses, I am going to have sec squared Moses. But where you have the case of differentiating tan Moses with respect to John, then you are going to use chain rule. This is like saying y is tan Moses, and you are differentiating tan Moses with respect to John, then you use chain rule. Adding b, it is tan x with respect to x, you don't need chain rule. You already know that it is sec squared x. But here we are going to use chain rule. You set the function in the bracket to be equal to u. That is, let u equals to 5x cubed minus 8x squared plus 1. If u is equal to this function in the bracket, then our y will now be equal to tan u. Now, the next thing is to differentiate u with respect to x. Don't forget that this is a polynomial function. You use the rule for differentiating polynomial. This is 3 times 5, which is 15x. Instead of writing back this 3, the rule says you reduce the exponent by 1 and you have 2. Next thing, 2 times minus 8 is minus 16x. Instead of writing 2, you reduce it by 1 and you have 1. This is a constant function, plus 1. When you differentiate 1, you are going to have 0. So that is the differentiation of this. Now you move to the next one. Differentiate y with respect to u. Don't forget that our table for differentiation told us that if we have y equals to tan x, when we differentiate tan x with respect to x, we are going to have sec squared x. So also, if you look at this table here, if you look at this question here, we have y equals to tan u. So also, if we differentiate tan u with respect to u, we are going to have sec squared u. So now we can use our chain rule formula. The formula for chain rule says that dy dx equals to dy du multiplied by du dx. And our dy du is sec squared u. This is sec squared u multiplied by du ds. Our du ds is this, which is 15x squared minus 16x. So now, what you just do to simplify this is you can just rewrite rearrangement. That is, this one is multiplying this. So you just have to bring this to the back to rewrite it. This is now 15x squared minus 16x. Open and close brackets, we rewrite this next to it, sec squared u. This is our answer, but don't forget that we change our u back to the function of x. U equals to 5x cubed minus 8x squared plus 1. So now we write u to be this. Then finally, the y ds is 15x squared minus 16x sec squared u. But u is this, which is 5x cubed minus 8x squared plus 1. And this is our differentiation for this function. So lastly, we are going to look at y equals to sine squared u. This is sine squared u. The table for differentiation did not tell us about differentiating sine squared u. It only told us about differentiating sine x. Like, the table did not tell us about differentiating sine squared x with respect to x. The table told us about differentiating sine x only with respect to x, but this is sine squared x. But sine squared x is the same thing as sine x all squared, right? So now we can rewrite sine squared x to be sine x all squared. They mean the same thing. This is another way of writing sine squared x. Sine squared x is another way of writing sine x all squared is another way of writing sine squared x. So you can replace this, and this is y equals to sine squared x. Now, since the table didn't tell us about differentiating sine x all squared with respect to x, we are going to use chain rule as well. Now you set the function inside the bracket to be equal to u, like we have been doing. Let u equals to sine x, right? So that y will be equal to u squared. don't forget that if you let u to be equal to sine x, this is sine x, you let it to be u, then y will now be u squared. Now this will now be let u equals to sine x so that y equals to u squared, right? So now differentiate u with respect to s. This is not a polynomial function but a what? Trigonometric function. From the trigonometric function, just look at your table. The table told you that when you differentiate sine x with respect to s, you are going to have cos x. So from here, we want to differentiate sine x with respect to s, we are going to have cos x. So the next thing is y equals to u squared. U squared, this is a polynomial. Differentiate y with respect to u using the polynomial rule. Don't forget that you have a coefficient of 1 here. So 2 multiplied by 1 will give us 2u. The rule says that instead of writing 2, you reduce it by 1. So 2 minus 1 will give you 1. So the differentiation of y with respect to u will give us 2u. Then we use our formula for chain rule, which says that dy ds equals to dy du multiplied by du ds. And this is equal to, what is our dy du? Our dy du is 2u, and our du dx is cos x. And don't forget that we usually change our u back to the function of s. U equals to sine x, so you replace it back. So finally, the differentiation of this sine squared x is equal to 2 sine x cos x. That is how to differentiate functions using chain rule. You can see it's quite simple and easier. This is very good for a beginner in differentiation. And I have some practice questions for you. You can ponder on to test your ability and practice to ensure you understand better. So the practice questions are these. They are just 7. For the first one, you don't need to use chain rule, but I believe for the rest, you have to use chain rule in order to get your dy ds. So if you have any problem or if you have any questions regarding this question or regarding this class and video, you can drop in the comment box below. And please subscribe, like, and share this video. So in my next video, I'll be talking about product rule and quotient rule. But before you can understand the concept of product and quotient rule, you need to understand the concept of differentiation table and also chain rule. Well, because in the process of dealing with product and quotient rule, we also need to know what? To know chain rule. Chain rule is a prerequisite to product rule and quotient rule. So now, don't forget to practice these questions. And if you have any question or if you have any problem, you can drop it in the comments box below. Please subscribe to this YouTube channel and like and also share the video. And also don't forget to click on the notification bell to get notified whenever we drop another video. See you in my next video.